Hello everyone, how are you guys doing? So to begin with, you can confirm that we are online and you can hear us properly and there is no lag. In the chats, I'm waiting. Please acknowledge. Hello people. Hello everyone. All right. Fine. So guys, I hope you already know of what series this session is. We are having this Geek-O-Lympics month here, correct? Hello Suraj. Mm. All right. So we are on the 11th day of your July, which is our Geek-O-Lympics month. This whole month we are coming up. We are regularly coming up with new sessions with different variety of topics which you can come here and learn, which you can know about more, so that it helps you decide your career well, your career paths well. Fine. So, whosoever already knows about Geek Olympics, it's great for them. But some people might be here who are attending this session, the series of this session for the first time. Let's for them tell what Geek Olympics actually is. Just give me a second. I'll be presenting my screen. All right. Okay. So kindly confirm if my screen is visible. People in the chat, can write +1 if you are able to see my screen. Hello, Tejas. All right. Got the acknowledgement. Thanks, AXL. Fine. So to begin with, see, Geek Olympics is a whole month, and it's going to be very, very, very useful to each and every audience that we have. See, this is complete guidance to you guys. Each and every day, there are going to be more people who are going to be telling you about the industry. They are going to be experienced people. They are going to be all the professionals who are going to be talking about their journey in these sessions. And these are not just these sessions, but on the top of it, on the regular manner, we are having different discounts, we are having different quizzes, we are having different giveaways for each and every field and for each and every course that we serve. You can take a look here. We have different sort of events. We have Code Extreme, in which if you are consistently following our POTD problems, in a regular manner in this July, you're going to be getting some awards which are apart from the regular ones, which are on the top of the regular ones. And then if you are solving a weekly challenges constantly throughout this month, there are some awards for that. And if you are if you are finding a job, we have job arena, we have live stage, we have hack wars, we have fun zone. In fun zone we have some quizzes aligned up which are both in offline and online mode. And then there is geekster. So just similar to that, we have so many things going on. And for each and every day, or for most of the days, we are having offer of the days, right? So for today, you can see we have DSA live for working professional and month full stack development course for the biggest sale, right? So it is up to you guys how you want to utilize it. Okay, this whole month we are having different and very interesting topics to cover up. Be consistent here, follow up. It'll give you a very clear vision of what to do, when to do, and how to do. Correct? So people are going to be coming here from the industry to give you the insights so that you can make better decisions for your career. All right. Now continuing about today's topic. Just give me a second. Fine. Continuing about today's topic. The title is From Data to Insights, the Journey of a Data Scientist. So, we are going to be having Sampoon Ratanjan here, who has 8+ years of experience in the field of data science. And he is a perfect guy who is there to guide you for the data science journey. Today, in this session, it is going to be about how we are going to be taking a lot of data and how we can convert them into insights. Sampoon is going to be telling you the whole process. And then we will talk about his journey. We will have a conversation with him, and we will talk about his journey, that from where he began and how he is a data scientist, a very successful profession. All right. So Sampoon, let's start. Sampoon is here, guys. Hello, Sampoon.
Hey, hey, hi Devashish, and good evening, guys.
All right. So he'd be taking over and he'd be telling you all about how you can convert data to insights. And then we'd be having a conversation with Sampoon where he'd be talking about his journey. So stay here till the end to know how Sampoon has done everything right. Okay. So thank you so much, Sampoon, for coming here. And please, audience is waiting to start. Let's start the session.
So, guys, let me know when you guys can see my screen, and I'll start. So, I guess it's visible. So, thank you, Devashish, for that intro. I'm basically here because I love data science. I've been doing it all of my professional life, and I have a huge liking to teach. Right. So, moving on directly to the overall, topic at hand, uh, who is this? For whom is this session intended? Right? Who are the intended audiences? People who have coded professionally, people who have never coded, people who have worked, want to work, or who work with data currently. Right? And most importantly, it is for people who want to get into data science. Right now, so there's this post called full stack data scientist, and you will hear a lot of buzz around it. But what you need to understand is what actually is a full stack data scientist. So a full stack data scientist is a data scientist who can not only model create a model around a business application, but he can also integrate and deploy it. So what that means is that the role of a full stack data scientist is more diverse and requires the application of those model app development and analytics. So just wanted to show you how huge the work of a full stack data scientist is. So obviously you need to know about software engineering. I'll get into the depth of it more in future slides, but just let me tell you what portions a data scientist, a full stack data scientist should know. Not just software engineering, a full stack data scientist should also know database management. Obviously, they should know data science, right? They should also know full stack, how to create applications around their model. They should also know DevOps. They should also know about clouds, your cloud service providers, whether that be AWS, GCP, or Azure. And finally, and probably most importantly, they should know about the business domain they are about to work in. Right? This is the holistic view of what a full stack data scientist is. Now, a full stack data scientist might not need to be an expert in each of these fields, including data science, but he should know a lot about each of these fields. Right? So let's talk about the learning path. So let's talk about the best practices. Obviously, Git is very obvious. If you want to track your changes, collaborate with the team, you should know Git. You know, Git makes it effortless to create independent lines of development, and by using it you are automatically creating a distributed backup of your code base. You should also know shell. Yeah, you should also know shell. So shell scripting, why should we learn command line interface when Ubuntu and other flavors of Linux have such established graphic user interfaces? Well, While GUIs provide a user friendly interface, they often have limitations. You cannot do remote work on them, you cannot do any sort of automation or scripting, and you will never have fine grained control on them, right? Another thing is knowledge of PEP 8 in Python, right? PEP 8 is a coding standard. So, good coding style is like using correct punctuation. You can manage without it, but it makes things easier to read. Uh, so this it is important because while your code may have only one author, that is you, but it will have multiple readers. And as with styles of punctuations, there are many possible variations. And in that case, when you're working in a team, it is a good idea to agree on a common, consistent style. Always remember, readable code is much better than efficient code. So, what is model encapsulation? It's just wrapping your model in a well defined interface. So, for example, Fast API is really, really popular nowadays. You can encapsulate your model in Fast API. It is highly performant and efficient, much more comparable to Flask. It is much more scalable and easy to use as well. Docker, everybody with, especially a full stack data scientist, should know about Docker. One of the biggest advantages of Docker is it provides consistent reproducibility. Remember, you never want to say it only works on my machine. That is a statement that you should never want to say. It only works on my machine is one of the biggest issues in the industry right now. So database management. So there are many database paradigms. However, a data scientist needs to know only these three paradigms: SQL, NoSQL, and a newly released paradigm, vector databases. So here are my recommendations for each. For SQL, you need to know Postgres. For NoSQL, MongoDB, and for vector databases, Pinecone. I'm moving slightly quickly because we have a lot to cover. Let me know if you have any questions. Right. So SQL databases, if anybody is not aware, it is it can be said to be equivalent to your Excel tables. NoSQL databases, they are equivalent to your JSON key value pairs, right? And again, this is not a proper analogy, but it might help you to understand it. Vector databases, this is basically new and kind of complex. So basically, they store your model embeddings, such as text embeddings and image embeddings, audio embeddings. So your model will require everything to be converted to numbers, right? Whether that be text, image, audio, video, whatever kind of input, right? So that representation of those data formats into numbers is called embeddings, and your vector databases can store them in a very efficient way. They currently are kind of groundbreaking in data science. So yeah, let's talk about data science and traditional machine learning. So for cleaning, exploration, and validation, let's talk about these three tools that you I recommend you use. For those who are not aware, Pandas is a library that helps you. It's a Python library that helps you in data manipulation, cleaning, and analysis. Similarly, Seaborn is an advanced Python library that helps you in analyzing data by visualizing it. See, although we can use pandas and Seaborn to solve complex issues, however, for simple analysis, simple cleaning, and even simple visualizations, I would highly recommend you use Excel, right? Even for the simple visuals, you can for the simpler visuals, you can create them in Excel in under a minute, which is much more efficient than pandas and Seaborn, right? And as data scientists, we care about the results and not about the method of the results, right? Yeah. So Python, again, everybody is aware of it, is the premier language for data science nowadays. sklearn is the most popular machine learning library in the world. With sklearn you can create entire machine learning pipelines. You should actually look into pipelines of sklearn, right? PyCaret is another popular library. One commonly used class of PyCaret library is called the AutoML class. It does a lot of heavy lifting for you, you know, and as the name suggests, it's basically an automated machine learning library. So let's talk about deep learning. What you need to learn for deep learning. uh, TensorFlow, nowadays is mostly an optional thing to learn. With such heavy abstraction libraries available nowadays, you might need to learn either PyTorch or Keras for training your deep learning models. Keras, Keras, is mostly for pro. So PyTorch is generally used for R&D, creating new architectures and things like that, whereas Keras is more production ready. And there is a trend in the industry of everybody is nowadays using PyTorch instead of Keras, even though Keras is much more production ready, right? Somebody is asking, what is your viewpoint on the new Mojo language? It's too early to tell. If it works, if it works well, then it will work really well, right? There are a lot of things that you are trying to recreate in Mojo that are already existing in Python. So I would say it's too early to tell, but it's a good thing that if it happens, it will be really, really good for data scientists. So full stack, you need to learn how to create your dashboards. You should be aware of how to use Streamlit and Gradio to present your model outputs in a UI by using very few lines of code, right? And with Hugging Spaces, you can host your Streamlit and Gradio dashboard to share your model UI with others. So basically, it allows it allows you to host your model. It allows you to host the dashboard that you have created, right? All for free, right? And share it uh, with others. Please remember, you cannot use Hugging Face Spaces for commercial purposes, but yeah, for research and sharing and visualization, you can use them very well, right? So let's talk about MLOps. In yesterday's session, I was talking a lot about MLOps and how MLOps is such a huge field. One of the most critical activity and one of the most uncommon activity right now is model serving. So model serving, you should be aware of PyTorch serve, TF serve, and K serve. So PyTorch serve is for PyTorch, TF serve is obviously for TensorFlow, and K serve is for Keras, right? So model serving is the process of taking the model that you have trained and making it always accessible. So uh, so let me explain that bit. When you try to make an inference on your model, you will always have to load your model. That is, what that means is that you will have to bring your model to your currently running or currently execution environment, and then and only then you can make a prediction. Now, in today's day and age, in today's era, when your models are very large, your model load time will be very huge, right? Now, what model serving does is it takes that model, exposes it as an API, and keeps it always accessible, right? You can make a prediction anytime without actually loading the model. So I myself personally have seen that model serving for a 30 GB model. Earlier, it was taking 60 seconds and to predict, and now the prediction time has reduced to 2 seconds, right? so so with model serving, your model load time and prediction time can be reduced by 98%. So machine learning, is an iterative process. You will have to perform multiple iterations and experiments to reach a solution. However, you should always keep track of your experiments. There are some tools to track model weights, parameters, training data, and test data. So, for example, DVC is data version control. If your training data keeps increasing, or if it gets keeps on getting modified, what you will need to maintain a track of which model was trained on which data, right? Otherwise, there will be a lot of confusion. This is where DVC comes into play. Then we have ML flow. ML flow is basically you're tracking your in DVC, you're tracking your data, and in ML flow, you're tracking your models. So, which model performed how much, what was the accuracy of this model, which data set was it evaluated on, which metric was it evaluated on, what is the version of the model, what libraries were used, what was the versions of those libraries. All of those things will be tracked in ML flow. For example, I have seen that if I used an older version of sklearn, right, maybe they changed the formula, they changed the definition of that function, but I saw a very small increase in the accuracy, maybe 2% or 3%, but it was there. Kubeflow is used with Kubernetes, where it is basically to track your deployment. So So, uh, w- how your deployment is currently functioning? What was the success ratio of your model? How many hits did it actually was it actually able to serve? Right? How much of what is the current scale of the model that you are have deployed? Right? Things like that. So all of these tracking services do things differently, and they do different things, but you need to be aware of these, right? So let's talk about the DevOps portion, the actual core DevOps portion, right? So Kubernetes is an orchestration tool, and that means a lot of things. But one of the most important meanings for a data scientist is that it can scale your model automatically. You don't have to manually go in and uh, say, okay, now that my number of requests have increased, so let me put in two replicas of the model instead of one. Jenkins is actually used for your CI/CD pipeline. It allows us to continuously deploy things after they have been tested. It allows for single click deployments. And Terraform is something that is used for infrastructure as a service. So what that means is that all you need to do is that you write some code that specifies, okay, this is the machine that I want to for my model, right, for my application. This is the services that I'll use. These are the configurations of the services that I'll use. And then you push that script. It's called a TF script, right? And then you push that script to a pipeline, and then your servers and things will be created automatically. This overall flow is called infrastructure as a service. So, okay, sorry. Let's talk about clouds. So, what is a CSP? So, cloud service providers, uh, uh, maintaining your own servers within your office premises, right? And maintaining the network, the security, and the external connections, the ports, and everything, right? It was a huge hassle. That is why AWS and GCP and Azure and Snowflake, these are very common cloud service providers. They are fairly cheap compared to having on-prem servers, right? Instead of having buying a very expensive laptop, you might take up an AWS account and set up an EC2 server. That will be quite useful for you, right? But you don't need to know everything about these CSPs. For example, maybe as a data scientist you don't need to know what a glue job is or what a EMR is, but you definitely need to know what EC2 is, what IAM is, what S3 is, what Textract is, what SageMaker is. For GCP, what is compute, storage, PubSub, things like that. So you don't need to know everything, but you need to know, again, you need to know a lot of these things, right? Finally, I would just like to close by saying that these are some recommended books to actually understand the business domain, right? And these if you read these books, you will actually know how to understand the business domain, because each business domain, whether that be BFSI, whether that be healthcare, edtech, retail, every business domain is different from each other, right? But if you read these books, it you will be able to understand how to work in those business domains. So the first book I am recommending is Storytelling with Data. You can learn how to communicate your results and analysis by reading Storytelling with Data by Cole Nussbaumer, right? One of the best books I've ever read in data science. It is so crisp, so clean, and it is amazing, right? Then you learn what questions to ask business stakeholders to basically convert a business problem into a technical problem statement. For that, you should read Data Science for Business by Foster and Tom. And finally, let's say you have understood the business domain, you have converted the business problem statement into a technical problem statement, and you have uh, shared your results of your EDA and everything. Now everybody is okay with the model that you are going to deploy. So what architecture is the model going to be deployed with? So, how are you going to design your machine learning systems? You have to learn how to design and deploy optimal machine learning solutions. For that, I would recommend designing machine learning systems, right? So, yeah, any questions right now? Any questions right now?
So audience, we are open to taking questions for from all the slides you have seen.
So
So
somebody is asking, what is better, data science or data analytics? See, each serve their own purpose. Those are two different fields. If you're, it would be like comparing apples to oranges. They might be related fields, but it ultimately depends on you. It has to be your call, right? So people say that data science has more money or things like that, but that might not be the case for each and every scenario, right? Okay.
and
And what other questions do we have? Mm,
Dhananjay is asking, is it possible with JavaScript, as JavaScript is growing in AIML also?
yeah, again, I answered such a similar question in yesterday's session as well, Devashish. So in the future, things like TensorFlow JS and PyTorch JS, think these models, they will be deployed at the client side. That is basically within your browser itself, right?
To keep me
What
to
that
keep things
helps,
more faster, right?
yeah, yeah. So what that helps in doing is that you don't have actually have to set up huge massive servers. We can just utilize the RAM of the laptop of the end user itself, right? So this is the future, but to be very honest, the progress in this particular space has been fairly slow compared to in other spaces such as generative AI. How do you approach problem solving in data science project? uh, is chat gpt helping in day-to-day life of data scientist? Can a fresh graduate get a data scientist role? So yeah, a fresh graduate can get a data scientist role. I'll order those questions and I'll answer those questions in order, right? So a fresher can obviously get a data scientist role, provided your resume does show that you have done something outside of your coursework that is related to data science, right? Again, you can pick up very small projects, right, that that are available on the internet, or you take up some problem statement that you are interested in and try to solve that problem statement using data science. You can put it in your resume, and that will be a differentiator, right? Is ChatGPT helping in day-to-day life of data scientists? It depends on the person. To be very honest, it I have not used ChatGPT much. I have used it, in terms of working on it, taking doing some projects around it. But I don't ask ChatGPT. I didn't create this deck using ChatGPT, or I didn't ask what are the things that a data scientist needs to learn. So but I have colleagues who are using ChatGPT quite extensively. It depends on person to person, right? What is the difference? How do you approach problem solving in data science projects? So, Turva, this is a very huge question. I'll put a pin on it and take it up in a bit. I hope that's okay with you. What is the difference between the three domains: data engineering, data analyst, and data science? So, for data engineer, if I have to there are a lot of things a data engineer does, but if I have to answer it in a few words, it's basically managing organizing data in an effective manner so that it can be utilized for later purposes. That is the data engineer's work, right? There are a lot of things in between, right? And again, I'm simplifying it. The data analyst's job is to convert the business problem statement into a technical problem statement and do the initial analysis around it. And the data scientist job is to uh, create a model with the data, whatever the data engineer has prepared, to solve the problem statement that the data analyst has prepared, right? And if you look into my deck, many people are nowadays asking for full stack data scientist, but they'll never say data full stack data scientist. They'll just say data scientist, right? So that is the expectation of the industry. It's not right, but it is what it is, right? So like I said, the data scientist will do the work of a data engineer as well, software engineer as well, DevOps person as well. So yeah, that's the truth. It's the harsh truth of the industry, but it is. So does doing MS in data science help land a six-figure job? No. Just doing an MS in data science will not help you do that. You will have to do a lot more things than that to get that job, right? Uh, what impact would products like ChatGPT have? Again, it depends. So with a lot of people are doing extractive work with generative AI. If you catch the drift, so yes, you can give ChatGPT a dirty data set and it will clean it for you, but that is something called as extractive work. But what is ChatGPT? What does the G stand for? It's generative, right? It needs to create new things. There are better tools other than ChatGPT to do the same work, right? They will give you much better accuracy. Uh, so this might be a controversial opinion, right?
Sampoon, I think we must continue
Yeah.
because the further session that we have is of discussing with Sampoon his journey. And along with that, you can keep on adding your questions. And as Tejaswara is asking, so we will surely ask that question. But let's keep the session going on, because we have already answered so many questions and we are not stopping here. Keep on adding your questions. We'll be picking up in the middle. All right. So to begin with, as Sampurna has already answered so many questions, which was really, like elaborative to people who were having little doubts about the industry, he is the perfect person to answer those, right? Now, moving ahead, we are going to be discussing more about his journey, how he started, and how he is doing, what he has done to become such successful in his own field. All right. Fine. So, Sambon, if we have to begin with, like sharing your experience as when you were starting your career, what was the beginning like?
So, you know, in the beginning of my career, when I joined, the title data scientist didn't exist in India.
All right.
So I had to, you know, I joined basically as a software engineer, but I was doing data science, right? So I had the opportunity to, because it was such a nascent stage, right? I had the opportunity to, learn everything, learn the conceptuals of everything before actually implementing it,
All right.
right? For example, let's take a example of a very simple machine learning model. Let's take XGBoost, right? It was available 10, 15 years ago as well, right?
Yeah.
But nowadays it's just a one liner, right? To implement it, it's just a one liner. I had to write 150 lines of code, 200 lines of code just to get there, right? So yeah, that was interesting. Uh, it it was harder to do things back then, but it also means that I know the conceptuals of it. I understand each of those parameters because I spent hours, days to understand and correct those parameters, right? So yeah.
All right. As you moved ahead in your career, so what in your experience were the key steps involved in transformation of data, like from raw data to meaningful insights? What in your beginning, what how you were doing it?
So understanding the business process is the most important aspect in actually converting. So insights don't come in a directionalness mode. You have a direction कि भाई मुझे insights इस direction में generate करने हैं, right? I'm sorry to use Hindi, but and so you need to understand the business process. You need to create a relevant hypothesis around that business process, right? And then you actually start with the work, right? You identify and collect relevant data around that hypothesis. Then you create something called a business to data flow. So what that means is that uh, in this particular leg of the process of that business process, this is the data that is relevant. In this particular leg, this is the relevant data, so on and so forth. And then you link all the data,
Okay.
right, for each of the legs. So in regular terms, that is simply called data merging. But even in your data merging, you are trying to map your business to your data, right?
Okay.
And after you have merged the data that actually represents the business flow, then you can do some sort of feature engineering, selection, cleaning, and then interpret the features, right? What does it actually mean? And after that, you can visualize your data or your features to make your interpretation simple and clear. And then finally, you obviously communicate and report your insights.
And that you have already stated about processing and cleaning. I would want to know, like, what was your approach for data processing and cleaning? And if you want to tell about some challenges that you might have faced in that phase.
So, uh, like I said, I try to understand the business process first. I try to map each table, column, data point to the process steps in the business process. So this involves examining and a lot of like staring at the screen rather than typing, right? This involves a lot of examining the data, the schema, the variable types, and any accompanying documentation or metadata, right? This in itself is a very huge process, and understanding the context and the meaning of the data. Um, so understanding the context and meaning of the data helps in making me, informed decisions for how to clean this particular variable, right? Or how to detect outliers.
like that. Yeah.
Is there an echo?
Okay. Let's see the comments.
So, uh,
There is an equation. All right. From the next time, I'd be doing that. Thanks for pointing it out, Dhananjay.
Turva has asked a very interesting question. How do you handle missing data in a data set? I would just like to say a couple of words on it. Uh, so different strategies can be employed to handle missing data. You can remove rows or entire columns with missing values, but you need to analyze that, is 20% of the rows of the items missing, or is it 80%? Right? If a column has 80% of the rows missing, then it might not provide useful information. And you can obviously impute values. If it's like 20% or 30%, you can impute values on the basis of simple statistics, uh, mean, median, mode, or sometimes even use models, simple models. For example, you can do a linear regression kind of a model, or you can perform something called multiple imputations. So basically, you take a lot of data set and you impute on the basis of that particular data set. So let's say you take the average of the previous 5 data points to predict the next missing data point, right? This generally occurs in time series data. Hmm.
I hope that answered your question, Tejas. So moving further, Sampoon, like very interestingly, you have spent so many years in this industry. You already have done so many projects. So is there any like a couple of projects which were very memorable to you, and you have those projects as your badges that yes you have done that. So if you want to discuss some of those and the key takeaways that those projects had for you.
Uh, so although I cannot share too many details of the project, but a project that I took up was with a bank, one of the biggest banks in India, and it was to identify fraud in UPI transactions. So so I had we not I me and my team had built multiple models. So because, like I said, machine learning is an iterative process, right? So one model was a very simple KNN model, right? It was giving me an accuracy of 97.8%. I remember those numbers even to this day, right? But it took less, but the time performance was very awesome. It took like a few milliseconds to predict, right? And another was a very complex, very deep learning model that gave us about 99.4% accuracy, but but each run took about 3 seconds. Now this is a bank which has millions of UPI transactions happening on each day, not month or year, each day, right? So we had to go with a simpler model because time complexity was more important if the accuracy was nearby. And it was really hard to let go of that model that was performing better. But ultimately the simpler model was more close to the business requirements, and that was the key takeaway. The business requirements are the most important metric of your model, not precision, recall, accuracy, loss, right? If your model is unable to be utilized in the business process, then it is worthless, and that is the reason most data science projects fail.
But it
uh,
does.
yeah.
It does, right?
So
When a model that you have made with so much efforts is that's getting rejected only because of the business requirements.
yeah.
That is what I feel. Okay,
uh,
so
Axel, we can use KNN regressor for handling missing data. But KNN regressor, not KNN classifier. Okay. Yeah. Sorry. Please go ahead.
So again, that we are discussing upon your experience. So
Mhm.
during the journey, if we have talked about memorable projects, but what were the challenges? Were there some of the challenges that were tough for you in your journey?
So,
And
so
yeah,
it will sound like a stupid answer, or like not a stupid answer, a goofy answer, but data collection is still the biggest challenge in the industry. The
the
rest of
very
the
first
things,
step, the very first
yeah,
step, the biggest challenge.
yeah, the rest of the steps are, uh, somewhat they fall into place, right? But if data collection is not done properly, your entire project will fail, right? And uh, you know there's a figure provided by Gartner that 70% of all time in any data science project is for data collection and cleaning, right?
So,
And
is there any hack or like a particular process that you have found for yourself which is suitable and which works very fine for you for data
you,
collection?
you have to own the project. You have to you have to take up ownership, even from the client, right? The client should feel like कि भाई ये तो मेरा प्रोजेक्ट है, ये ऐसे क्यों मुझसे लड़ रहा है, right? You
Okay.
have to fight to get the right data, because it's not that anybody has any malintent or anything. It's just that everyone is busy in their daily activities, right? So yeah, if you had to restart like from the beginning, to what would be your roadmap? So AXL, my roadmap would be the one that I showed in the deck. I would have, you know, started with Excel firstly, right? Then I would have taken up Git, then Shell, and then coding practices. Because, just a few days ago, I had the unfortunate opportunity to work on a project that went live 8 years ago. So it went live 8 years ago, right? And there was a new bug that came in, right? And I saw my code and I didn't understand it, right? So if I had the opportunity, I would learn software engineering, then work on databases, then the entire flow that I described in the overall deck, right? So yeah,
That sometimes is the biggest issue, and
yeah,
I can really confirm that because that happens sometimes with me a lot. I cannot understand what the code I've written some time before. That
yep.
happens a lot.
So
That is why
documentation, code, best
documentation,
practices,
everything,
yeah,
very important.
yeah.
Right. So talking further about the near future, if you want to suggest like how the shape or the of the industry is going to change, or what are the advancements that we might see in the near future, what is like basically your point in that?
When you say near future, I assume you're talking about more than 5 years from now, right?
Correct. 5 years, a decade, how it is going to look like.
So one of the biggest revolutionary items would be, quantum computing for ML, right? And with quantum computing for ML, uh, we a new scale will open up, and it will feel like what the scale at which we are working nowadays, that will feel ridiculously small. So for example, we have models that are trained on hundreds of billions of parameters, right? Maybe a decade from now, when quantum computing will be used for machine learning, we'll be using it on maybe thousands of trillions of parameters. And not even a decade from now, maybe 5 years from now. Another very interesting thing I feel is that we'll soon see the introduction of something called no code deep learning. So anybody with a mouse, keyboard, monitor will be able to create a deep learning model via some UI, via some maybe some configuration file changes, things like that. And then obviously I've talked about it a lot, but data scientists will, increasingly will, they will need to collaborate with experts from different domains and assimilate knowledge from them. Data engineering, data analyst, business analyst, right? DevOps, things like that. That is going to happen.
That is the destiny of a full stack data scientist.
Yes.
So, that point is very interesting. While how can a person create a no code deep learning models, and I believe that it could be a topic for a whole new session. Correct, because it is so vast. But sticking on to today's topic and learning from your journey, if
Mhm.
you know like if you are at your place and you look back, and if you want to mention some of the mistakes that you might have made in your journey, because right, we are all humans, we make mistakes, we learn from them, and we convey those mistakes to the audience and to other people so that they do not make it, right? So what are some of the mistakes that you might have made and you want other peoples to know and be aware of?
So uh, that's actually a thinker. So no, again, just to reiterate, when I started, the data scientist title didn't exist in India, right? But if I had to change one thing, I would have taken more time to learn. Just taken out 8 to 12 months of my life just to focus on studying properly with a roadmap, and rather than on the job, I had to learn everything on the job. So neural networks are coming, we need to implement this, I need to learn it before implementing it. But I had to learn it like overnight sometimes, right? Things like that have happened with me. And personally, I feel that kids won't have to face these issues now, because they have college courses that cater to data science. However, again, no matter what somebody is teaching to you, it's up to you what you assimilate and what how much homework you are going to do with it, right? So yeah.
Well, that is really important. How what you like you are consuming some content from anywhere. That is another thing. But what you are doing with yourself is the main thing that is gonna walk you through. That is gonna take you. So, Sampoorn, to sum it all up, if there could be any of the tips for all the new coming data scientists and all the aspirants who are wanting to come into this field, if you want to tell something to that, or something to them.
Yeah. So even Axel asked a related question. So and this is to everybody, and Axel, to you as well, right? Instead of learning a new language, or learning a new skill, what I would recommend is that you focus on solving interesting problems, right? You pick a business domain, right? Whether that be BFSI, healthcare, edtech, infra, right? Things like that. And you try to solve a business problem using data you can scrape off of internet, right? So there are many data resources. Google data sets is a huge one, right? You can scrape data of Kaggle, right? UCI machine learning repository is again a huge source of data, right? You will have uh, so for example, loan approval prediction, you will get data set for this on Kaggle. Churn prediction is another topic that I talked about yesterday, right? You will have data set for this available somewhere on the internet. Let's see, support ticket classification, you will have a data set somewhere on the internet, right? It's not just text classification that you're doing, you're solving which support ticket needs to go to which person or which department, right? You're solving a problem statement. Yeah, on the way, if you learn a few data science technologies and models, good, excellent, right? Let's see, employee retention prediction, right? So I would just like to say one thing. In the beginning of my career, I took a very small problem. It is again a very small problem that interested me, right? I took up a location's weather parameters, you know, humidity, temperature, wind speed, etc., and classified the weather into good and bad. With that, I was able to learn simple classification, right? Now, uh, then what I did was, for the same location and time period, I took the tweets, right? That the people from that location and time period are giving you, right? Earlier we could get the Twitter API had location wise access as well, right? And then I did the sentiment analysis on that, right? I could come to a very strong conclusion, very seemingly obvious conclusion, that when the weather is nice, people are nice. But now I have data to back it up, right? People are in a good mood when the weather is good, and they are angry, and again, a very small problem statement, right? And I just linked sentiment analysis with, classification, things like that. So uh, small problem statements that might interest you or that are already available on in the internet, right? Look that up. And just one thing I would like to say is that, data scientists are expected to solve problems. You have to become a problem solver and not a coder, right? That is, if you get one thing out of this session, you just like put this word in, this sentence into your heart, that you're not expected to become a problem to become a coder. You should become a problem solver, right?
Right. Sampoon, well, personally speaking, I have hosted you for 2 days, and the journey that you have told and everything that you have put here, I also feel like completely enlightened. And just to getting to know all the things that are really happening are very useful, right? And I really hope that audience have enjoyed as well as learned a lot from it. And we are having a good number of audience right now, and I want you guys in the chats to tell how was the session. Sampoon is here. You need to tell uh, like Sampoon, that was a great session. You need to write that in the comments. All right. I can see some people already being very consistent throughout, asking the questions, getting very engaged because, okay, people are saying, Dhananjay is saying best advice. Right. So, Sampoon, thank you so much for coming here for and along with us catering the audience and telling them the real things going on. So we are really grateful, and so is the audience, and we really look forward to have further more sessions with you. I enjoyed it personally, and I hope the everyone in the audience did too. One request to the audience: once the live chat ends, and all the people who are seeing it after the live, don't forget to comment and don't forget to follow Sampoon and along with JFG. Okay, so stay with us. The following month is going to be full of such sessions. We are going to be covering a lot of things. Again, thank you so much, Sampoon. Let's wrap it up. And I enjoyed it. Audience enjoyed it. I hope you had a great experience too.
Thank you, this was really awesome. Thank you, Devashish.
Thanks, Sampoon. Thank you, audience. We'll be winding up now. Thanks.
Thank you.